Function blah 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 gives the number of bacteria in a science experiment where X is the number of days. And that's how I would always approach these word problems. I know word problems continue to freak you out, but as you're reading something, especially if it gives you an equation, what you want to be looking for is what do the pieces of the equation stand for. As soon as you see X is the number of days, let's label X as days. Okay? So the nearest whole number, how many bacteria will there be after 4 days? So 4 days, is that my X or my Y? My X, yeah. So let's just put 4 in for X. 30. What is it? It does say round to the nearest whole number. 115. Taking Trevor's word for it, do we believe him?
No.
I get 115.
Yep.
Anybody still not getting 115? Okay. All right. Good to verify. You should verify yourself. Okay. All right. Does this explain, or does this satisfy an exponential function? Explain. Do you remember what an exponential function has to do with the coordinates? Yeah, it has to have a common ratio where you're multiplying by something. So we would need, and you're looking at just the y's, we would need something that multiplies this to this to this. So what I want to know, listen to my question and then I'll tell you how to answer my question. I want to know 0.25 times what makes 0.5. And if you aren't sure, do 0.5 divided by 0.25. Should be 2. Agree? Okay. What was that? It was outside? Okay. I know, that's what I thought too. I was like, Judy, man, that Taco Bell is really stuck with you, huh? Oh my gosh. Okay. Oh. Okay. 0.5 to 1.5. 0.5 times what makes 1.5? Times 3. And if you didn't know, you could do 1.5 divided by 0.5. So right there, do we have our answer? Yeah. If I were to check this, I would find that this were 4. Okay? But I would say no, because there is no common ratio. Don't say there ain't no common ratio.
Julie already wrote 10.
Disgusting.
I said for because it is B and then mine B.
Oh, that's fine. Okay. No, because there is no common ratio. Okay. And again, just to remind you, a common ratio would be where this number was the same over and over again. Okay? All right, number 6. The number of students at a university is 1,320 and the number increases by 8% each year. Do you remember how we set up these problems? What's the little formula? Y equals, it's tiny, close, A,
B squared.
A, B, where's the X go?
Exponent.
Exponent, good. Y equals AB to the X. What's A? Yep, in a minute. This one for A, it's just 1320. Bree, what you're thinking of is that B value. And we have to decide if we're going to add or subtract. Yeah, because it increases. So as soon as you see increases, that means plus, and we want to always add it to 100%. So we want to do 8% plus 100% is 108. 1.08. Yep, move the decimal. 5 years, yep. Oops, 1.08. What'd you get? 1939.5. Okay, and what is this? What are we talking about?
How many students?
People. Yeah, I would take 1939 or 1940. Okay, you could round up or down on that one since it's people, but don't leave me decimals. I don't want half people, okay? Nope. Well, that's fine. Students. Okay. Half-life. Do you remember half-life? Mm-hmm. Yep. 0.5 goes in for your B. So our starting amount is, now first of all, where does the 212 go? Ignore that. Yep, that's just part of the name, remember? How much are we starting with?
100.
We're starting with 100. Because it says we're starting with a 100 gram sample, so that's your A. Bree's right that it's going to be 0.5. And then how do we figure out what goes up here? Yep. We have to divide the total time divided by what the half-life is. So I would do the total time is 242. And I want to divide by 60.5. 4. So that means 4 is going right here. Yep. 6.25 grams. Okay. 6.25. Okay, 8 says determine which kind of model represents this data set. We didn't talk about square root data set. I hope that this one doesn't come out to be a square root. I don't think it does. Okay, so let's graph it real quick and take a look. -2, -2. Oh, be careful. Look at how they numbered their y-axis. That's -4. It is super weird. So -2, -2 would be like halfway between 0 and 4. -1, -1 would be like this. 0 and 2 would be like this. 1 and 7. And 2 and 14. Okay, there's something I don't like about this problem too. This is what it should look like. Yeah, except what rule does this break about exponential functions?
Oh, it goes past my.
Okay, here's the thing, and we haven't really talked about this, and I don't want you to worry about it in terms of your exam, okay? Exponential functions by themselves never cross the x-axis. But if I take an exponential function like this, 3 times 2 to the power of x, and I do something crazy like -5 on the end, that -5 is going to take my whole graph and shift it down. So it could cross the axis. And the asymptote would be down here someplace. Okay? So I agree. That's dumb. I wish I would have done that problem before I decided to assign it to you. So that is an exponential function based on the shape, but it's an exponential function that's been shifted somewhere else on your graph. Okay? Because usually that's one of the big things we look for. So I'm glad you guys are thinking about that. But don't worry about that for your exam. I won't throw one like that at you. Is that it?
Yep.
That's it.